exSILentia has developed and markets a tool to do this probabilistic calculation. We call the tool exSILentia. We developed the tool for our use, but we do offer it for everyone else, of course. I'll show you some examples of this calculation using the exSILentia tool. I modeled a common SIL3 safety function. 3 transmitters, 2 out of 3 vote, into an Emerson Delta V SIS redundant module with the automatic proof test or advanced diagnostics from Emerson. And then I used a dual blocking valve using a solenoid and actually it was a Fisher GX is the valve I chose for the example. Now, in the first instance of this calculation, I'll show you what most people commonly do. They assume clean service for the transmitters with no impulse line plugging. And when we do that calculation, the screenshot shows that we get a strong risk reduction factor above 2,000, which is a reasonable SIL3 level. If, however, we recognize that impulse line plugging does exist, we will model that with the exSILentia tool by saying plugging is unlikely. Now, what does that mean? Roughly speaking, if you have 100 transmitters, you would get plugged impulse lines in 1 instance per year. As you can see, the risk reduction factor drops to a little over 300. We've lost our SIL3 design. None of these plugged impulse lines are detectable with normal transmitters. A manual proof test must be done. In the third example, we have modeled the plugged impulse line failure rate as 80% detectable with the plugged line diagnostics. And you'll see that we've gained back most of our risk reduction factor with a value of over 1,000. We've got our SIL3 design back again. A good question, where does this 80% diagnostic coverage come from? Well, it must be done with a combination of test results and field experience. As part of the certification process, exSILentia witnesses test results, and we have witnessed test results of the plugged line detection in both gauge and differential pressure applications. We've witnessed a restriction on a manifold, and the plugged line detection does a very good job of detecting it every time. Now, that doesn't mean in the field we're going to get 100% diagnostic coverage. To get good field data, you must really interview experienced users of the product. And exSILentia has started doing that with the help of companies like Rosemount. Based on the interview results to date, we have estimated 80% coverage in gauge applications where it's really doing a pretty good job. Now, you might say 80%, that's not a very good number. True, but we don't have enough data to really prove it's a better number yet. Hopefully, when we get more data, we will see better results. It's a lot of fun to see new technology that will make the world safer and save customers money due to less downtime or fewer false trips or and less proof testing. As we move forward in the future, I'm looking forward to seeing the real impact of this by getting better data, and hopefully we'll see it's even more significant than we imagine right now. And of course, I expect more of this good stuff from Rosemount.